Hi guys, welcome back. What we're going to be looking at today is 1.3 growing dots, the Ready, Set, Go, as you can see right here. All right, let's go ahead and jump right in. So for this first part, each question has both an A and a B part. For part A, you're going to use the given table to identify the indicated value for n. Then for part B, then using the value for n that you determined in A, use the table to find the indicated value for B. So obviously that's a little confusing. There's a lot of finding n using A and B. It'll make more sense once we look at a couple. All right, for number 1, A, when f of n equals 12, what is the value of n? So we're going to go to the line that says f of n, since we know the f of n number, and we're going to go until we can find 12, which is right here. So when f of n is 12, the value of n is 5. So there's our answer. Now for part B, what is the value of f of n minus 7? So f of n minus 1, 5 minus 1 is 4, and then f of 4 is 7. So there's our answer. We'll do one more of these just to kind of help you a little bit. Let's do number 5 over here. When f of n is 27, so once again, we go to the f of n line. We find 27, which is right here. What is the value of n? That would be 8. And then for part B, what is the value of f of n minus 6? So 8 minus 6 would give us 2. And f of n, when n is 2, is negative 3. So there's our answer. So it takes a little bit of thought process, because obviously we have this 8 here, and we're doing 8 minus the 6 to get 2. So most of you, my guess is, are going to want to write 2 down, but that's not your answer. We need to know what f of 2 is. That's the negative 3. Okay, so be super careful as you're taking and going through here. For part A, you're always going to be looking at the f of n row, and you'll get your answer in the n row on top. And for part B, you'll start with the n row, and you'll get your answer from the f of n row. Hopefully that didn't confuse you more. All right, the next section, comparing explicit and recursive equations. So use the given information to decide which equation will be easiest to use to find the indicated value, find the value, and explain your choice. So explicit equation is the kind of equation we're most used to. It's y equals 3x plus 7. It's the actual equation. The recursive equation is less often used. It's not one that we talk about as often, for sure. And it's now equals previous term plus 3 in this case. So basically, recursive is always going to use your current number equals your previous number, either times something, subtracted by something, added to something along those lines. So it uses the pattern that we talked about before. It really uses that to help you find your next term. Recursive equations are always best used when we have the previous term to the one we're trying to find. Explicit equations are best used when there's a gap in the information. So for this one, we have term number 1, 2, 3, and 4. We have the values, so we're going straight from 3 to 4. So like I said, the recursive is the one we use when there aren't any gaps in the data. So we're just going to take 16 plus 3 to get 19. So the value of the fourth term is 19. Now, our explanation, and yes, once again, I do expect you to have an explanation down. So for this, recursive is what we used. And it's the easiest because we know the third term. So we can add 3 to get the fourth term. So like I said, recursive is when there's no gaps. We're going straight from one number to the next. Explicit, gaps. It's easiest to use when there's gaps in the information. Okay? So if you were taking and doing one that was an explicit, let's say we had 1, 2, it skipped 3, and then we had 4, we'd take the 4 and plug it in for x and then solve. And that will work on every single one. So if we tested that out, I'm going to do it over here off to the side. 3 times 4 plus 7. 3 times 4 is 12 plus 7 equals 19. So we got the same answer both ways, but this is how you would do it using the explicit. And we'd only do that if there were gaps. Okay, so hopefully that makes sense to you guys. Like I said, recursive is when there's no gaps. Explicit is when there is gaps in the information. And then you're just going to plug it in and solve to find your next term. All right, so that's what you're going to be doing on 8, 9, 10, 11, and 12. Now, on these ones here, you don't have a table. So it's saying the value of the 8th term is 78. The sequence is increasing by 10 at each step. It gives you the two equations and wants you to find the 20th term. So it's giving you what term you know. So be careful as to what term it's asking you to find, and in terms of thinking about how you're going to take and do that. All right, the last part of this is looking at evaluating exponential equations. So what we're looking at here is the exponential. So exponential is when, if we have sequences, it'd be when we're multiplying, whereas if we're adding or subtracting, those are arithmetic sequences. Arithmetic is your keyword for this lesson. Arithmetic is your keyword for this lesson, spelled like so. All right, so these would be what's known as geometric, and they are going to grow very, very quickly. So we want to evaluate the following equations when x equals 1, 2, 3, 4, and 5. So that's set. And we want to organize the inputs and outputs into the table of values for each equation. Let x be the input and y be the output. So for this, basically what we're going to do is we're going to plug each of these 5 numbers into the equation up above and then see what the output is. So for, we're actually going to do number 15 together. So we're doing 15. So if we plug 1 into this, we have -3 to the first power. It's going to stay -3. For 2, we have -3 to the second power. So we take the 3 to the second power, which gives us 9, and then we multiply by the negative. So we end up with a -9. Now, the reason that that is not positive is because there is not parentheses around the -3. So the only thing being taken to the power of x is the 3, not the negative. So 14 and 15 are different. Even though they look the same, these parentheses completely change 14, okay? So be careful with that. So now if we take 3 to the third power, we're going to get 27, so we'll end up with a negative 27 for 4. 3 to the fourth power is 81, and then it's going to be negative, and 3 to the fifth power is 243, so it'll be a negative 243. So anytime there's a negative number when we're dealing with exponents, if there's not parentheses containing the negative and the number, like there's in 14, and then having your exponent on the outside, your answer will be negative every single time. When it's like this on 14, it's not going to be negative every single time. So really do your math and double check and be careful, okay? All right, so remember your keyword for this lesson is arithmetic. If you have any questions, feel free to ask. Have a wonderful day.